Today our topic is uniform and non-uniform motion. Last day periodic and non-periodic motion was discussed and the answer of checkpoint 1 is given at the last of the video. So starting today, uniform and non-uniform motion, follow along page number 34. First thing is, what is uniform motion? If an object covers equal distances in equal interval of time along a given straight path, then its motion will be considered uniform motion. And on the other hand, if an object covers unequal distances in equal interval of time along a straight path, then its motion will be considered non-uniform motion. Now follow along the figure 2.12 given here. See, one car is starting at 6 a.m. then till 7 a.m. it is covering 40 kilometers distance, and up to 8 a.m. it is also covering 40 kilometers of distance. So in equal interval of time of 1 hour and 1 hour, it is covering 40 kilometers and 40 kilometers. So uniform distances in uniform interval of time. So this is to be considered a uniform motion. But on the other picture, it is starting at 1 p.m. until 2 p.m. it is covering a distance of 50 kilometers. Again up to 3 p.m. it is covering 40 kilometers distance, and up to 4 p.m. it is covering 55 kilometers of distance. That means the interval of time is uniform, 1 hour in each, but the distance that is covered is different in all three cases. So that's why it is considered to be a non-uniform motion of this car. The next topic is distance. So what is distance? The actual length of a path covered by a moving object is the distance traveled by it. See at figure 2.13 and 2.14. Here a person is starting from position A, moving up to position B, then to position C, then back to position D, again back to position A. So in this way he is covering a distance of 30 kilometers, then 30 meters, then 40 meters, then again 30 meters, then again 40 meters, a total distance of 140 meters. So this is the total distance that person has covered. Again on a circular path, starting from position A, moving the whole circle and coming back to position A again. So this is the actual distance covered in the circular path. A distance is a scalar quantity. It has no direction. SI unit of distance is meter. Distance cannot have a negative value. Okay, next is speed. Okay, you all have seen speedometer in bikes, cars, etc. that shows how fast the car is moving or how fast the bike is moving in accordance with the time. So the distance covered by a moving object in unit time is called the speed of the object. Speed is also scalar quantity as it has no direction. SI unit of speed is meter per second, but commonly another unit is used in case you are measuring the speed of a bus, speed of a train. We can measure it in kilometer per hour. Speed is always taken to be a positive value. Example, like a bus is traveling at a speed of 60 km per hour. So moving object speed cannot be negative. Next is how to calculate the speed. Speed is equal to distance traveled by the time taken, okay, or V equal to S by T. Here V is considered to be the speed, S is the total distance that is covered, and T is the time taken. The speed of a car may not remain same at all time. If that is the case, then we have to calculate the average speed, and the formula for calculating average speed is total distance traveled by total time taken. An example is given at page number 38. Example number 6. Here Robert is driving his motorbike on a straight highway and covering 30 kilometers in the first hour, 50 kilometers in the second hour, and 85 kilometers in the third hour. So you can see that 1 hour interval, that is constant, that is uniform, but the distance that is covered in the first hour it is 30, second hour it is 40, and the third hour it is 85. So now we have to calculate the total distance, that is 30 plus 50 plus 85 is 165 kilometers, and time is taken, that is the uniform time, 1 hour each, so total 3 hours. So total distance by total time taken 165 by 3, it is 55 kilometers per hour. That is the average speed of robot. This is how we calculate any average speed. Practice these numericals given in page number 37 and 38 for calculating speed and average speed. Next is weight. Okay, so weight of an object is the force with which earth attracts it. So attraction of earth is one of the most important thing if you are trying to calculate the weight of an object. Force of gravity have a major role in weight calculation. Weight is a vector quantity, okay, because the direction at which the earth is attracting, we are calculating that one also, so it is a vector quantity. Formula for calculating weight is W equal to m into g. W equal to m into g. Okay, and the SI unit is Newton, also commonly used kilogram force or kgf. W equal to m into g, that is mass into acceleration due to gravity. Now weight is different from mass. Mass is the quantity of matter that is present in an object, but weight is that value multiplied by the acceleration due to gravity, that value. Okay, so for a object, mass is always same at all places because the matter present in it is constant, but weight is different in place to place. Weight differs because earth's gravity also varies from place to place. So if in any place earth's gravity is less, then weight will also decrease in that case. So suppose in moon has 1/6 of the gravitational force of earth, so any object here will be lighter in moon. Like any object of 36 kg weight in earth will be 1/6 of the 36 kg, that means 6 kg on moon. The SI unit for weight is Newton, but commonly kilogram force or kgf that is also used. 1 kgf is equal to 9.8 Newton. Here the difference between mass and mass and weight is important one. The value 1 kgf is equal to 9.8 and 1 gram force equal to 100 Newton. These two relations are also important. Next, mass is measured in beam balance, but weight is measured in spring balance. So try to do the checkpoint 2's answer, and checkpoint 1's answer is given at the last of the video. Thank you.